What's up guys, we're going to be solving the very first challenge of the OWASP juice shop, which is finding the scoreboard. Now the premise is quite straightforward. We simply need to find the URL that takes us to the juice shop scoreboard. It's there somewhere, we just don't know what the URL is. Now this is a standard part of pen testing. If we think about the various HTTP routes that are inside a web app, that constitutes our attack surface. And the wider that surface is, the more potential vulnerabilities we can find. The problem we have is perhaps those web routes, the different URLs that we can visit, are not just listed for us in a nice, easy to access document. In some cases, it can be quite hard to find the various routes available to us. But once we find those routes, we can then start testing those routes for various vulnerabilities. Now, this is an example of that. There's a route we want to find. It has information for us that's going to be valuable. It's going to have information regarding the additional challenges that are available as part of the OWASP juice shop. So how can we find this route? It's going to partly depend on what type of web app we're testing and the structure of the underlying technology. We can find many of the routes simply by clicking on various links on the page and seeing which URL we end up at. Other routes are going to be a bit trickier to find and in some cases might involve guesswork or some type of brute force tool like Dirbuster. But before we do that, let's see if we can get a feel for the landscape of our app, because it might not be so complicated in this case. One of the tools that I like to use is known as Wappalizer, and it's going to give us information regarding the technology stack that's used to generate this web app. Now we do know some things about this app already since we installed it from source, so we know that it's running Node.js on the back end. But let's take a look at some of the other technologies that are running here. Firstly, take note of Angular. Now what is Angular? Angular is a JavaScript framework. It makes it easier for developers to run complex JavaScript on the front end without having to deal with the extra overhead and complexity of running vanilla or standard JavaScript. We're also interested in this Webpack tool. It's a JavaScript bundler. What it allows developers to do is to harness the power of Node.js, which runs on the back end, when writing their JavaScript modules. Webpack takes those JavaScript modules and compiles them to a front-end friendly version. In other words, it can be used by the browser, and it also usually bundles all of the JavaScript into one file. So if a developer has written several modules on the back end using the power of Node.js, Webpack can then compile those into a single front-end JavaScript resource. What does this tell us as a pen tester / hacker? It means that the entirety of the app's JavaScript is likely to be bundled into a single front-end file, which we can likely find using our browser. There's also something else interesting that we can notice about the way that routing works on this app. Now we're using the Firefox browser right now. It has something known as DevTools, and we can usually open that with the F12 shortcut key. I have these various options at the top. You can see Inspector, Console, Debugger, Network. We're going to head over to the Network tab right now. We're going to refresh the page, and we're going to see which files the app pulls in. Well, we can see a lot of files there, and one of the earlier files is this main es2018.js. It's very likely that that's the bundled or web-packed JavaScript front-end file that we're looking for. We'll get back to that shortly. Let's see what happens if we visit another route on the app. It can be any route. Now, let's say, for example, that in a typical web app, when we request a new route, it's going to send a request to the backend. So that could be Apache in the case of running a PHP app on the back end, or in this case, we know that it could send a routing request to the Node.js backend. Now, when that happens, this DevTools network pane on the right-hand side should get completely cleared and all of the files get loaded up again because we are receiving a brand new route from the backend. But let's see if that's actually what happens. Let's visit the photo wall. Now you can see that none of these routes get reloaded. In fact, what ends up happening is extra files get appended to this list, but it feels as if we're on the same page. nothing actually gets completely refreshed. If we head back to the home page, you can see this again. Some extra information gets appended to the list, but all of these initial files stay exactly where they are. Now, why is this the case? It's very likely because this app uses something known as front-end routing. In other words, a routing request is not being sent to the back end. All of the routing information is very likely stored in that main es2018.js front-end JavaScript file. And when we request a new route from the app, it's handled on the front end by the JavaScript, which then replaces what we can see, i.e. the view, with the part of the app that we're requesting. Now, this type of behavior is fairly common for JavaScript-heavy apps. And you can see if we check out the Angular documentation, remember that's the framework, the JavaScript framework that's being used by the Juice Shop app, we can see an entire section on routing. We have this section here, defining a basic route. Now, if we scroll down slightly, we can get a feel for how this works. It's different with different JavaScript frameworks, but they offer similar functionality. We nearly always have the option for front-end routing. We don't have to take that option. It's still possible to route everything via the backend, or route some things via the backend, but we have this option to make use of the front-end routing. And we can see that somewhere in our JavaScript file, we can define these routes. So here's an example. We have a JavaScript routes array defined here. In fact, it's an array of objects, and each object is one potential route in this sample app. So you can see when the user visits this first route called first component, it loads up this first component, which is defined elsewhere, into the view. If we scroll down a bit further, we can see sample HTML here of how this would work. Notice this HTML comment here. The routed views render in the root to outlet tags. Then we can see these HTML tags here, root to outlet, close root to outlet. So whenever the user visits a route, the front-end JavaScript will automatically update the view based on the route that was requested. In other words, there's no request sent to the backend, apart from some extra files that are required. So we saw that there were some additional routes appearing when we visited a new route in the Juice Shop app, but it was just requesting things like images from the backend. There was no extra request that's sent to the backend for the route itself, because all of the routing is done via the front-end JavaScript. Now, when we're dealing with an app that handles its routing via the backend, it's essentially a black box for us. Unless we can compromise the system in some way, although those routes will be stored in a backend JavaScript file or a backend PHP routing file, we won't be able to access that because it's on the backend. So we won't be able to access that nice, convenient list. So we're forced to either compromise the system in other ways, or maybe just guess at what the routes might be, or use a brute force method as we mentioned earlier. However, when we're dealing with front-end routing, it means that all of the routes that are going to be handled by the front-end JavaScript must be defined in a front-end JavaScript file somewhere. And here's where we come back to our main es2018.js, which at this stage we suspect is our Webpack JavaScript file that has all of the information regarding how the Angular framework is going to manipulate the page we're looking at right now. So our objective is now very clear. We're going to check out that JavaScript file and look for routes. So let's take a look at that. Now, if I double click on that, I can open that in a new browser window. And I think the problem is quite immediately obvious because this is a bundled JavaScript file. There's literally no spaces in the entire document, or at least very few. This is very, very hard to read. Now, the truth is we can run some searching on this. So for example, if we hit the Control and F key, we could start searching for routes. And you can see route matches a number of results, and we can just run down these. And we probably would eventually stumble across the routes this way. But we can do an intermediary step, which is just going to make things a little bit easier. And that is we can use the debugger tab in the DevTools. So let's head to debugger. We can see all of the JavaScript files that the app is pulling in. We're really only interested in this main es2018.js. Let's click on that. Now, if we expand the DevTools window, we can see that same file again. In some ways, this might appear even worse because it's the entire file, but now it's just on one line, so it's just really, really hard to read. However, if you have a look at the bottom, we have these options here. One of them is called Pretty Print Source. So let's click on that and we'll see that it adds the spaces back into the document. As we can see, that's much easier to read now. This is valid JavaScript, but it is still the bundled version of the JavaScript. So it's probably not quite as easy to read as the original node.js files, which were eventually compiled into this single front-end JavaScript file, but it's still much easier to read than it was when there were 0 spaces in the document. So we're going to run a search in this document to see if we can find the roots. Now, obviously, if you know that the goal is to find a root that's probably called Scoreboard or something similar, then the temptation is just to search for Scoreboard. But that's very specific to this challenge. If we're pen testing a different type of app, it's a black box pen test, and we want to enumerate the various roots, then we're not going to know what the roots are called. We're not necessarily even going to have any clues. We just want to find where the roots are defined in this bundled JavaScript file. Now, if we just take a quick look at our Angular documentation, and of course, it is possible that a developer is going to use a variation on this, but in most cases, the whole point of using a framework is that we don't have to write our own bespoke JavaScript. We can just use some infrastructure that's already in place. So very often you're going to find that the same patterns are going to be used when defining roots. For example, we've got this path followed by a colon, a space, then the name of the root. So what happens if we search for that in our debugged JavaScript? So we're literally going to type path followed by a colon, and we get one result there. Let's scroll down to some additional results. Well, here appears to be something that's already related to routing. So we've got path administration. It even tells us which component, presumably Angular component, is going to be loaded into the view when this path is typed into the browser. Let's have a look through all of the different paths. Now, if we were trying to enumerate these different roots, we'd take a note of all of these roots because we want to check them for vulnerabilities. Now, if we keep going down these routes, we're hopefully going to come up against a root that's going to be called Scoreboard or something similar. And there we go, path Scoreboard. Then we can see it's loading this component MO once we've tried to visit that Scoreboard root. Now, what you'd obviously do is continue going through this and making a list of all of the different routes that we can test at a later point. But for now, we're just going to try out that Scoreboard route and see if it solves our challenge. So it's simply going to be the standard home URL, which appears to include a hashtag in this case. And we're going to type Scoreboard as part of the URL. Scoreboard. Let's press enter. Let's see what we get. And notice we get this pop-up. You've successfully solved the challenge, Scoreboard. Find the carefully hidden Scoreboard page. We'll be having a look at this in later videos because it's going to give us clues regarding the various other challenges that are available as part of the Juice Shop.